All right, here we go. I think this is just a really interesting question where something that wouldn't necessarily immediately make you think of, oh, I need a trig function to answer this, but a very real world problem that this, in fact, is the best way to solve this problem. So here we are. The depth of the water at the end of a pier varies with the high tides throughout the day. And the pier is kind of just where they're along the shore where the boats come in and dock. But today, the high tide occurs between 4:15 a.m. With the depth of water being at 5.2 meters. The low tide occurs at 10:27 a.m. with a depth of only 2 meters. And so first we're going to find the trig equation that models the depth of the water T hours after midnight. So that gives us a hint that midnight's going to be kind of our zero, our origin right here. And then find the depth of the water at noon. Lastly, a large boat needs at least 3 meters of water to moor at the end of the pier. During what time period after noon can it safely moor? So we've got here that it needs 3 meters. The low tide's only 2 meters. That's not enough water, but the high tide is 5.2, so that is enough. We just need to figure out the right time that that boat can be there. All right, here we go. So I've sketched out a horizontal and vertical axis. It says after midnight. So if think of this right here being midnight, and thinking of this in military time, this would be 100 hours, I think is how you would say that. But no, no minutes, starting from 0, right there at midnight, and then each hour, so this would be 1 a.m., 2 a.m., 3 a.m., 4 a.m., along the way is kind of where we're going to go. Our vertical axis, which normally would be y, is going to be our h value for right now. That's the height. And again, the horizontal axis is our t. So let's quickly sketch what an equation might look like, where we're going to have h, the height, is equal to the height of the water, is equal to that a value times whether we use sine or cosine. Let's just, so we'll say sine times the b value, then the time t minus our horizontal shift plus our vertical shift. Okay, so let's get to this problem now. We've got a high tide, so there's our, that high tide would be our maximum, and it's at 4:15 a.m. So let's kind of sketch that out there. So we'll call this right here 4:15, and if we were going to put that in decimals, that'd be 4.25. 4.25, that's a quarter of an hour, and it's a height of 5.2 meters. So it's up right over here. 5.2 meters, that's 4:15 a.m. at 5.2 meters. And again, the minutes, remember there's 60 minutes in an hour. So if we just did 15 divided by 60, we get that 0.25. Next, we've got a low tide occurring at 10:27. And I'm going to cheat real fast. So 27 minutes divided by 60 minutes, 0.45. All right, so 10.45. That's going to be, that's just the hour as a decimal. That'll be easier for us to use. Now, that's the low tide right here. So low tide at 10:27 is only 2 meters. So there's our low tide. So the water came up, heading back down. That's the lowest it's going to be. It's going to head back up again after that, and so on and so forth. That's what's happening as time goes on. So we've got to figure out how are we going to write this equation. So we'll need to find our a value. So how will we find our a value? Remember, that's the midline, the axis going right through the middle here. And to do that, we're going to take our maximum and our minimum, add them together. So 5.2 plus 2, and divide that all by 2, get the average. So it's going to be, let's see, 7.2 divided by 2 gives us 3.6. Okay, at the right there at the middle, it's 3.6. That's our V value. So plus 3, we give ourselves a little more room. So plus 3.6 at the end of the equation. Our A value, how far up and down is it going from there? Well, 5.2 minus 3.6 gives us 1.6. It's rising 1.6, which you can see as well. It's falling 1.6, going from 3.6 to 2. That's our A value. And whether you want to write this with sine or cosine is up to you. For me, the one that would make the most sense is that, hey, we've got a maximum right here that we can very easily use. Which one uses maximum? Well, it's going to be cosine. So let's write this as a cosine function. So h times, and that's also a maximum, so our A value is going to be positive at this point. So the A we said was 1.6. It's a maximum value that we're using, so we're going to go cosine. Now you could, if you wanted to, do negative 1.6 if you used this point over here as your horizontal shift. I'm going to use the maximum just because there's less conversions that we'll need to do. We don't have to worry about the negative. But you could write this with the horizontal shift of 10.45. Instead, we'll be using 4.25 right now here for the video. We're going to come back and find our B value in just a moment. But in here, we've got T minus 4.25. That's our horizontal shift. T minus 4.25. It's been shifted 4 hours and 15 minutes to the right. All right, so now all we need to do is find our period, so that we can find our B value. Okay, well, we've only got a maximum and a minimum. We don't know what the next maximum is, but we'll have to go ahead and reason our way through. I'm sure we can find that. If it came back up, wherever that next maximum would be, we would want the distance between those two, and that amount of time would be our period. Well, let's figure out how much time has taken place from the maximum to the minimum, because if we can figure out that length of time, then we can double it to figure out the length of the period. So how much time has taken place from 10:45, or sorry, from 4:15 on to 10:27 a.m. How much time has taken place? Well, we got 10.45 minus 4.25, and the difference is 6.2. So we got 6.2 hours from the maximum to the minimum, meaning another 6.2 hours from the minimum to the maximum, and our period then is those two numbers added together. So total is going to be 12.4 hours. That's our period. Now, using that period to find our B value, remember period equals 2 pi over B. So we've got 12.4 is our P. So multiply both sides by B, divide each side by 12.4. All right, so 2 times pi. And now that, after we multiply both sides by B, divide both sides by 12.4. So divide this by 12.4. And we've got right around just 0.5. Okay, right around just 0.5. The B is going to be right at 0.5 or 0.51 if we were to round up it. What was the value? I think it rounded up to 0.51. Let me double check. I don't want to waste time. Let me double check though off the screen. All right, sorry about that. Yeah, let's go ahead and round it to 0.51 because we got our significant digits don't it's not going to throw our value off a ton either way, but to 0.51. All right, so there's our trig equation, and again it says a trig equation because there's an infinite number of correct ones, but there's one possible, let's erase, but there's one possible answer. All right, so next, find the depth of the water at noon. So what we're going to be doing here is um, plugging in t as 12. So let's grab our calculator. Let me pull that up real fast. Okay, here we go. So we've got, this was the answer to A. And now for B, we've got our calculator, but we're going to find the depth of the water at noon. So that's when t is 12. So we've got 1.6 times the cosine of 0.51 of, or sorry, 0.51 times x, or our t value of 12, so 12 minus 4.25, and then plus 3.6. Get that in, and we get 2.497, so let's just call that 2.5. So b value is, or the height at that point is right around 2.5. All right, lastly, we have a large boat needs at least 3 meters of water to moor at the end of the period. During what time can this happen? And for that one, we're gonna graph. So we've got y equals, that'll be our h value, equals 1.6 cosine of 0.51 times x, that'll be our t value, minus 4.25, and then plus 3.6. And here's what that graph looks like. I changed my axes. So here's noon, and each tick mark is 1 hour of time. And so we want specifically when it's after noon. And I also want where, oh, let's get the 3 meters in there first. Sorry, so have another graph of just y equals 3. This is the height of when it's 3 meters. So anything below that, and the boat's going to crash. It's going to hit the ground. It's not going to go well for that boat. So we need these times above. And it's specifically, the question asked us for the times that are after noon. So count out to 12. It's this area right here. That's what we're looking for. Now to find that, we're going to use our calculate function, find the intersections. And we've got 12.73. So write this down over here. 12.73 all the way to 20.4. Sorry, it's kind of messy there. So the time is going to be between 12.73 and 20.4. So that's roughly, to answer the question, 12.73. That's right on. I'm just very roughly estimating right now. But between 12:45 and then t, the hours, and 20.4. That's let's go with 20. I guess we would call that 8. Subtracting 12 hours, so 8. Let's say like 25. 8:25, somewhere in there. That'd be p.m. All right, and we can find that exactly. If you want to keep on watching, feel free to. If you don't, you've got the main gist of what's going on. But yeah, hope that helps. And I'll go ahead and find the exact values of those right now, though. All right, so if we had kind of the equation we're going to do, so if these are our minutes, we got 73 minutes, or sorry, 73 over 100 equals our x value over 60. So part over whole equals part over whole. 73 times 60, and then all divided by 100. So just multiplied both sides by 60 right there. And that gave us, so 43, so 12, let's see, that's actually going to be then 1240, let's round that up to 44, 1244. And for the other one, this is going to be 40 hundredths, so just 4/10. And this time we'll multiply 4 times 60 divided by 10 and 24. So off by a minute there. 8:24 p.m. All right. Hope that helps.